All right. Interestingly, this technique can also be used to solve problems that could be solved by writing a single equation, like the next one. I have to tell you, I'm not really sure why in the world we would do it this way, but we'll humor them. While traveling on business, Eldrick bought a $50 prepaid international cell phone to call his girlfriend Lindsay. Calls cost $7 per minute. How many minutes has he used if the display shows $32.15 remaining? To answer this question, we could think about two different equations. One states that the value of the card V is $32.15. Write that equation here. Yeah, don't hurt yourself on this one. V equals $32.15. Next, we can write another equation that states that the value of V started at 50. Okay, the value of V started at 50 and decreased by 7 cents for each minute used. And they're going to let X stand for the minutes used. All right, next they want to complete the table. Again, with the first equation, our outcome is $32.15 for each one of those. I'm going to pause this. Feel free to continue to write that for every single outcome. Okay, and so with the second equation, we're going to substitute the input values of 0, 100, 200, etc. in for X, and then we'll get our output V. All right, are we getting the same thing? I hope so. All right, let's go on to the next page. I wanted to mention, before we go to the next page, I don't see anywhere where we have exactly the same thing here in both tables. Like the $32.15 is going to be in between here somewhere. So it looks like our X value for our solution is going to be somewhere between 200 and 300. Okay, so I'm pretty sure we'll see something similar on the graph. All right, so on the graph, not only do I have an issue with being able to perfectly graph my V equals $32.15, I'm, doing my best to, first of all, draw a straight line. And secondly, is that actually $32.15? All right, and so for our second equation, we know that the y-intercept was 0.50. And then I'm going to look back at the table and see that we had points like 143, 236, probably kind of went a little bit too low on that other one, 329, 422, and 515. All right, so clearly we certainly do have a solution somewhere. I don't know exactly what it is. Like I said, it's between 200 and 300 for my X. I know that my Y, or my output, is 32.15. That's pretty obvious, but I don't know exactly what my X is. Well, what are we going to say? Maybe 260? That's a good a guess as any. It says, use your graph to estimate the solution to your system of equations. Well, we said maybe it's 260. And 32.15 we know about. How confident are you of your answer? Not at all. Okay, so then on 18 it says, now solve the system by using the substitution method. And did you get the same solution? Well, probably not. Okay, so Remember, V was equal to 3215. It certainly would be a lot easier to go ahead and substitute that 3215 in for V in our equation where we had the 50 minus 700ths x. So let's subtract that 50 from both sides. And I get negative 17 and 8500ths equals negative 700ths x. Let's divide both sides by 700ths, negative 700ths, sorry about that. And I get x is 255. So my ordered pair would be 255 for my x and 3215 for my v. And it says, did you get the same solution? No, we did not. And it says, how would you determine the second coordinate of the solution? Well, we already knew that the v was 3215. Okay? All right, so you might want to try the Did You Get It number 2 on your own. Go ahead and pause this and let's at least look at what your equation should be. Okay, a taxi company charges a fixed initial charge plus an additional $1.80 per mile. Let's let X be the number of miles. Let's let C be the cost. How long was the taxi ride if the total cost was $14.62? Clearly, we could just substitute that $14.62 in for C and then solve. Okay, we're going to end up with the fact that the ride was 4 9/10 miles long. Just see if you can get that on your own.